Hey all you cool cats and kittens out there, Spencer with a Physics 106 video, and today we are going to talk about magnetic fields and field lines. So as you can see here, we have a magnetic bar, and we're going to go talk about some of the properties of magnets and magnetic field lines. To start off very simply, all magnets, as you can see, have a north side and a south side of them. Just something very basic. Something else that's very basic about magnets that I'm sure all of us have noticed before is that as we put magnets together, they are either attracted to each other or repelled from each other. And that is just something that most of us have noticed as we played with magnets growing up. So let's talk a little bit about why that happens. So all magnets have magnetic field lines from them, and they look a little something like this. So as you can see here, magnetic field lines are always going to go in the direction of north to south. That's just one of the properties of them. So as they travel from north to south, like I said, they're just going to go this way. But if you were to look at this magnet on the inside of it, you would see that the magnetic field lines continue to go this way, where they travel south to north. And as you can see here from these lines that we've drawn, magnetic field lines always form closed loops. And right now I've only drawn one magnetic field lines, and they have multiple magnetic field lines on them. Seem to be running out of room here, so let me move this over. Actually, we're going to keep it there. But anyway, so yeah, we can see that magnetic field lines are going from north to south on the outside, but as we look on the inside, they're going to go from south to north, and they're always forming closed loops. So we're going to make a note of that over here. So outside, it's going to be from north to south, and on the inside, south to north. And once again, important thing, always form closed loops. Okay, so those are just some of the basic properties that we know. Once again, as we talked about before, everyone's played with magnets before. And like I said, whenever we put them together, sometimes they'll repel, sometimes they will attract each other. And with magnets, if they repel each other, so if you were to put the magnets together like this, they would actually repel each other. But if you were to turn this magnet like this and bring it to it, they would attract each other. So that's another important concept that we need to understand, that that likes repel and opposites attract. Okay, so those are some things. Another just few things to note about them. Once again, this is just something that you've probably noticed with playing with magnets before, but the closer they are together, the stronger it's going to be. The farther apart, the weaker it'll be. Another important thing about the magnetic field lines that we've drawn is magnetic field lines will they will never cross, or yeah, they'll never cross each other. So the field lines, they will never cross. Field lines never cross each other. Yeah, we'll just say it like that. So you'll never see a magnetic field line. Up here on this one right here, you'd never see like a magnetic field line that came in like this or something like that. That just wouldn't happen. Okay. Another thing we can talk about with magnetic field lines is when they're drawn, the closer they are to each other, the stronger they are. So this one on the right, we have a lot of lines that are close to each other. As you can see here, these lines are a lot closer right here than these ones right here. So this magnet right here, these magnetic field lines would be stronger. So another thing to note, just as the lines are closer, the stronger they are. Okay, something else to talk about. Let's talk about another characteristic of magnets that I think is pretty cool. If you have a magnet and you were to break this magnet in half, sometimes we would assume that you'd have one end that would be north and one would be south. And that is incorrect. That's not the way magnets work. Magnets actually worked, if you were to break the magnets, you would end up with two new magnets. So you would still have a north and a south end, and you would still have a north and a south end. There is no such thing, or at least scientists have not found monopoles where it's only a north or only a south end. They always have two. It's always a die. So if you were to break these magnets once more, you would still end up with even smaller magnets with a north and a south, the north and a south, and same thing for these ones over here. So no matter how many times you break them, you're always going to have two. You're always going to have a north and a south. It'll never be like we see up here with one north and one south. Okay. I wanted to show a picture down here of, so this was just a way to visualize a little bit about magnetic field lines. So here they had a magnetic bar laying down, and they sprinkled iron fillings on this bar magnet. And as you can see, let's highlight this in red maybe. As you can see, there's kind of there's a magnet here, right? You can kind of see it laying down this way. And as you can see, you can't tell what direction the magnets are going from north to south, but you can see that they are forming these, these field lines. You can kind of see them going around here. And this is just kind of a visual representation of the magnetic field lines. You can also see that around, the ends of them over here, that the magnetic field lines are super strong. There's a lot of the iron fillings there, and that just shows once again that the closer it is to the magnet, the stronger it is, and the iron fillings that are farther out, they don't have clear magnetic field lines, as do the ones that are close to the magnetic bar. So that's a little bit of a real-world example, or kind of a demonstration to visualize magnetic field lines and how they work. So sometimes confusing concept, or something that's hard to wrap your head around, is what exactly are magnetic field lines? What are we trying to represent? And pretty much what it is, it's an electromagnetic interaction that is mediated by the constant exchange of photons from one charged object to another. It's a little hard to break down, a little hard to understand, but essentially these magnetic field lines are photons that are jumping from one charged object to another. And that is the best way I can explain that, but it's essentially what it is. A little bit hard to understand, but that's the best I can do with that. So one other thing that I want to talk about is just a real-world example with magnets. One thing that is interesting is the Earth. As you know, we have a North Pole and we have a South Pole. And this is the Earth, but anyways, we have the North and the South Pole, and then also, that with compasses, there's a north and a south, and there's always the needle that will point north. And something that is interesting is that As we talked about before, opposites attract and likes repel each other. So the North Pole of the Earth is actually the magnetic South Pole. And the same thing for the South Pole, that's actually the magnetic North Pole. Because the compass points north, it has to point to the opposite, which would be the South Pole. So that's something that's a little interesting, is our North Pole is actually the magnetic South Pole. And vice versa for the South Pole, as I mentioned. But that is magnetic field and field lines and the basic concepts behind them. Thanks for watching.